In this video, we're going to look at what's called the ambiguous case of the sine rule. And to do this, we're going to start off by trying to draw accurately the triangle ABC, where we have AB is 10 centimeters, BC is 4 centimeters, and the angle CAB is going to be 20 degrees. So let's think about what it's going to look like first. If we've got the angle CAB is 20, I'm going to make that mark down here somewhere. So I'm going to start over here. That can be our starting point. And I'm going to draw AB going up. And BC will then come down. So if this is A, we're going to have B up here somewhere. And we'll have C going along somewhere along this line. And I'm going to draw this properly, so I'm going to get out a ruler. And I'm going to measure it. We don't know how long this length here is, this A to C. We just know we've got a line somewhere going along here. So I'm just going to draw in a length along that. And then I'm going to do angle CAB is 20 degrees. So I'm going to get out my protractor and put that on A, that's on there, and I'm going to measure 20 degrees, and that's going to be here, and then I'm going to move my protractor out of the way, let's get rid of that, put that out of the way. So then I'm going to put my ruler back on here, and I'm going to rotate it up to go to that point. Fortunately for me, I can also do 20 degrees on the ruler, I can see, so that's perfect there. And that's going to be a B. AB is 10. So this is going to be AB. So we're going to draw from A up the ruler until I get to 10. Which is there. Perfect. I can get the ruler out of the way. So now our B actually isn't there. It's going to be this point here. So we've got AB is 10 centimeters. Let's label that as well as 10 centimeters. We also know the angle here, BAC or CAB, is 20 degrees. They're the two things that we were told. And we also know that BC is 4. So now we're going to work out where BC is going to be on this diagram. So if we put it in here, we're going to find a point where it's 4. Well, there we go. We've got from B, let's just make it a bit easier to draw. There we go, so it lines up perfectly there, down to there. That length there is 4 centimeters, which means that we have C is going to be there. But actually what we should note here is that that triangle has all the red, the green and the black 20-degree angle, but we could keep rotating our ruler here. And what we notice is when we get round to here, actually we get another point where if we were to join those up, we'd get another point where that line is 4 centimeters. And it still fits the same description. And actually that's what we mean here by the ambiguous case. The ambiguous case is because there's two possible triangles here. We've got the first triangle we drew, and the second obtuse angle triangle. So we've actually got, now if we think about what this is, we've got the triangle A, it went up like this, B, C, where this one was 10 centimeters, 4 centimeters, and this angle here was 20 degrees. But we also have the second one we saw there, which is when we had something more like this. This one is 10 centimeters, this one is 4 centimeters, and this angle is still 20 degrees. A, B, C. So actually here we have two triangles that satisfy the conditions we were originally given. So this is what we mean by the ambiguous case. There's two possible things. So when we're asked to find angle ACB, there's actually two possible ACBs. And if we just relabel this one here as C1, we also have this C here, which is C2. So this one here was C1, This one here is C2. And they're both possibilities. So there's two angles that we're looking for. We're looking for a C2B or a C1B. The two blue angles there. And there's two different ones. And we need to find them both. So let's use the sine rule here. Because we've got two lengths and the angles that we want or that we know are opposite those lengths. So it's the sine rule. So the sine rule tells us that sine of a CB divided by, well, that's this one or this, one of the blue angles. So that is divided by 10 because that's the one opposite. The sine rule tells us that that is equal to sine of 20 over the one that's opposite that, which is the 4. Now with a bit of rearranging, we get that from here we get sine ACB. So sine ACB is equal to, now it's going to be 10 sine 20 over 4. Which tells us, when we work that out, we get that that is equal to, then we can work out ACB from there by doing sine inverse of that. So we get ACB is equal to 58.76 degrees. Now clearly that's the one at C1, because that's the acute angle. So that tells us that this angle here is 58.76 degrees. But what about the one at C2, the other option? Well, what we have to notice here is those two green lines are both 4 centimeters. So we've got an isosceles triangle between C1B and C2, which means that this angle here is also 58.76 degrees. Which means that the angle on the other side is equal to 180 minus it. So the angle at C2, well, let's call it, this one was C1, we know now. The angle at C2 is 180 minus C1, or 58.76, which is equal to 121.23 degrees. So that's telling us we have two possible answers. Let's write our final answers down here in the box. Our two answers are either we have ACB is equal to 58.8 degrees, or it's equal to 121.2 degrees. Two possible answers for ACB here. Because we have this ambiguous case, we don't know which triangle we're dealing with. And this happens when we have the scenario where it's an SSA triangle. So we know two sides and an angle not between those two sides. We can get it. It doesn't always happen, but it can happen, and we need to be aware that it can happen. Now let's have a look at a second example. And in this second example, we're not going to draw it accurately, but we've been given that PQ is 40, PR is 30, and the angle PQR is 40. Now, I always look at these the same way. The angle that we know is the one, let's say it's on the left at the bottom. So we're going to have, this one here is going to be Q, and then we're going to have the PQ is going to be the one that we know is going to come up here. So we're going to have P up here, and that one's 40 meters. And then PR, well, this is the one that comes down here. It could be that we go down to R1, and that one's 30 meters, or it could be that we come down here, that one's 30 meters, and it goes to what we'll call R2. And we know that the angle at Q is 40 degrees. So this is the possibilities with R1 and R2. We need to be a bit careful because in this question we're not asked For the angle at R, we're asked for the angle at P. So we're asked to find this angle or this angle. Those two blue angles are the ones we need to find. But we're going to have to do it in exactly the same way. We're going to start off by using the sine rule. So in exactly the same way, we're going to find, first of all, the one that we found before. Let's do this in purple. Let's find this one here and this one here. So we have sine of PRQ over, well, this is over the one opposite that, which is 40. So this one's over 40. And that is equal to the other angle, the angle we know, sine of 40 degrees over the one that's opposite the 40 degrees, which is the 30 PR. With a bit of rearranging, we get sine PRQ is equal to 40 sine 40 over 30, 30, which tells us that PRQ, the angle PRQ, is equal to 58.98 degrees, or, now that's this one, R1, the other one is 180 minus that, or it's 180 minus 58.98, which is equal to 121.01 degrees. So there are our purple angles PRQ, either R1 or R2. But we're not asked for that, we're actually asked for P. So to find P, well, this is going to rely on the two different situations. If we're using R1, if we're doing the big triangle, then we've got to do the angle at RPQ is equal to, well, we can use the triangle now, 180 minus 40 minus the angle at R1, which is 58.98. And that one gives us an answer of 81.0 degrees. But we could also have, or RPQ, if it was at R2, it's 180 minus 40, because that's still in the triangle, this time minus the purple angle at R2, which is 121.01. And that would give us 19.0 again degrees. So our final answer is these two here. The two possible angles, two possible values of the angle of RPQ are either 81.0 or 19.0. So when we're dealing with a question where we've got the ambiguous case of the sine rule, that is, we've got two lengths and an angle that's not between them, we need to think about what the two possible triangles are. And then what I've shown here in green are those two that could be different. Always draw the angle in the bottom left and the one you don't know across the bottom. Then the angle draw the angle and the fixed length that goes with that. And then the other two will be the ones that come down in this sort of shape. It always looks similar to this kind of scenario we've got here. And then just be careful, are we being asked for the purple angles here, the angles that are in this case, or are we being asked for the blue angles, the angles at P? And we're going to have to use the sine rule and maybe the angles in a triangle, depending on which one we're trying to find. So that's how we find the two possible angles in the ambiguous case of the sine rule.